we've already identified doing the vertical and reflexive, but there's more than just vertical and reflexive. There are times when they're going to give you extra information. For example, they're going to tell you that CE bisects an angle, or they're going to tell you that A is the midpoint. So we also need to know how to deal with those given statements as well. So the rest of this page kind of helps you figure out where to put markings based on what you are given. So let's say that you are given, so here's an example of what it would show up like. You are given that A is the midpoint of CE. So what I'm going to do is on the picture, I'm going to mark the segment CE so that I see what I'm actually doing. And if A is the midpoint there, that would mean that A breaks this segment into two congruent segments. So if I'm given midpoint, what it's going to give me is a set of sides, and which sides in being specific, it would be CA, so C to A, and A to E. Okay. What if it says that GI is the GI bisects angle FGH? What if you're given that statement? What I'm going to do this time is highlight the angle FGH. So F to G to H. That angle is being cut into two congruent parts. So what are the two congruent parts here? It's going to be this side of the angle and this side of the angle. So I'm going to make this marking using the definition of an angle bisector. So that gives me a set of angles, and specifically which angles would be angle FGI, and angle HGI. Now that we've talked about midpoint and bisects, let's actually do a problem, what that might look like. So if you turn the page, problem number 7 here says that you are given that G is the midpoint of TY. So I'm going to highlight TY so I know where my tick marks are going. They're going on that segment. And if I have a midpoint, that means that point is breaking it into two congruent parts. So I'm going to mark those parts congruent. Once you make the markings, you have to say why you were allowed to make the markings. So definition of a midpoint. But then if you look at the triangle is not complete yet. I only have 2 sets of markings here. So you also have to revert back to what we did yesterday, which is the reflexive and the vertical. So the reflexive is when they come together and they share a side, or they have one angle exactly in common. But here I have a set of vertical angles. So because I made this marking here, I have to say why I can make that marking. And now my triangles are congruent. By, cover this up, side, angle, side. Okay. Now, yesterday, we looked at this one, problem number 3, and based on the picture here, we only had 2 things that were given. We could use the reflexive property to make this marking, but that was only 2 things. So we did not yet know how to deal with this bisects, but now we know how to deal with that. So if CE bisects DCR, I'm going to highlight DCR, and where that comes together, so angle C, there are two congruent angles. So I'm going to mark those as congruent. And because I made that marking, I have to say why. And then I already put this marking on there, but mark it again. So we have the reflexive property as well. Okay, so now my triangles are congruent because I have more than two, and I have angle, side, angle. But now that I'm ready for number 8 uses a criteria or a given statement that has the word isosceles in it. And so how do I deal with that? So again, I'm going to flip back. Now we'll talk about definition of isosceles, base angles theorem, and the last one, right angles theorem. All right, so the last three. So definition of isosceles. If you're given that you have an isosceles triangle, the definition of isosceles is that that triangle has two congruent sides. So we're going to mark the sides of the triangle congruent by definition of isosceles. So those sides specifically are TU congruent to TV, and then if I have a isosceles triangle where it's already marked as isosceles, so notice these markings are already there. So there's no given statement up here, but these are already marked. If you have an isosceles triangle, isn't it true that isosceles triangles, if the two sides are congruent, then the two angles down here are also congruent? So you can get a set of angles if you know that the triangle is isosceles by the base angles theorem. So those angles would be angle Q is congruent to angle P. Okay, and then the last one. This is a minor technicality, but we will be using it. Here, this angle is marked as a 90 degree. This is marked as a 90 degree. Those are not congruency markings. They're 90 degree markings. So what we can say is once we see those 90 degrees, I can say that two 90 degree angles are equal to each other. So angles by the right angles theorem. I know it seems like it's not necessary, but when we get to what we're doing in IC 22, you'll see that we do need to write that the two angles are congruent to each other. And our reasoning is going to be the right angles theorem. Okay, let's go back to those last two problems. Right here, it's given to us that we have an isosceles triangle. So when you have isosceles, the markings that you make are here and here. You mark the sides of that triangle congruent to each other by definition of an isosceles triangle. Here, we're going to use that right angles theorem here. to state that those right angles are congruent to each other. So that's here and here. I'm saying those are congruent, marking them congruent, right angles theorem. And then because I marked here, I'm also going to mark the base angles. Here and here. Could I also mark the reflexive? Sure, but you don't need to. I could have done the reflexive instead of the base angles theorem. But it would just give me a different criteria. So my triangles are congruent here. I have a set of angles, I have a set of angles, and I have a side. So if I connected the two angles, so start at one angle, connect it to the other one, is that side marked? No, it is not. So when you write down your two angles, do you connect the two A's by putting the S in between? Well, no, because my side marking was not in between here. So it'll go behind. Okay, final one. So we just learned a whole bunch of new criteria. So the tricky part is when you go to a problem that's a little bit more basic, you might try to over-explain the problem or use things that you're not given information for. So there's no given statement up here. There's no extra information, so there's no definition ofs. The only thing I can do in this problem is look for a reflexive or a vertical. So this side right here that they share in common can be marked as reflexive. My triangles would be congruent just with that one marking, and I would have side, angle, side. How do I know that it's side, angle, side? Well, again, I can take my two sides and highlight my two sides. Those two sides come together at this angle. Is that the angle that's marked? Yes. So that's why the A is in between the two S's. Okay, I'm going to go ahead and turn the page to the homework, and we can do one of the homework problems together. So this is in class, or homework 21, on the back side. There is one on the back side of the page that is not possible, so just take that into consideration here. I'm going to zoom in so that we can see the page a little more clearly. Okay, anytime you approach a proof, you always look at this given statement and look for a vocabulary word. It says isosceles, so I'm definitely going to use definition of. I'm going to look at the tick marks that I need to put, or put the tick marks where they need to be. And now I can make a choice. Do I want to add in the base angles theorem, or do I want to add in the reflexive? We did the base angles on the last problem, so this time let's do the reflexive. Okay, I do have the right angles. But on this problem, because my criteria is actually HL, You don't need to state that the angles are congruent to each other. They just need to be right angles, which they already are. So you don't need that. If you put it there as extra, it wouldn't be a big deal, but you don't need it for this one. If you're going to do HL and not angle, angle, side, you do need, the angle, angle, side would need the right angles theorem, but HL does not. HL is kind of its special own little thing. Triangle, so we've got FGI congruent to, and we'll go HGI. So that's the difference between the homework and the note, is the homework you actually have to put the congruency statement instead of saying yes or no. Okay, so the rest of homework 21, which is just the back side of it, which is page 20, that's the homework for tonight.